Hi, this video is going to discuss the week one network analysis and IDS IPS introduction on this document. So once we click this document, and we'll be able to see the detail of the introduction for the IDS and IPS. The purpose and objectives for this particular IDS IPS course. The main thing is to implement it to protect our network resources. Either it's hosted at your private business, or we can host it in a public cloud, such as using Amazon AWS or Microsoft Azure. The physical location really doesn't matter. The principle and the concept is it's the same. If you applied it to the cloud, we still have to move everything virtualized from your corporate, from your business into the hosting company. For instance, if we use AWS, then we'll still have to deploy our firewall as a gatekeeper for the users from all over the world to access it. Now, we'll go into the detail when we take a look at the topology. And the learning outcome objectives, the most important one I'm going to cover here is we want to cover in the whole course, including using the vulnerability assessment tool, Kali, Wireshark, to do the network analysis as a troubleshooting tool. And we're going to use a Kerpool process hacker using Cisco IPS IDS standalone, and also the virtualized Cisco box and the virtualized Linux standalone Snort and pfSense, and also the security onion, which is also Linux-based IDS IPS system loaded with either Snort or Suricata. So let's take a look at the topology for the IDS IPS. In the more traditional IDS IPS, we will have the security appliances. For instance, there's a firewall here connected to the internet, and there's the internet attackers that we are going to protect ourselves from. However, the internal switch network connected to the monitoring system, it will connect it to the server, it will connect it to the internal user. According to certain reports, 60 to 80% of the attack comes from inside as well. So we definitely cannot ignore the internal attacker. So if we deploy the IPS in here as an inline bridge, so it's like a bridge. Bridge is like a two-port switch. It doesn't know anything about the IP, even though we will put an IP address here and then connect it to a management port, and using this management box, what's so-called the out of band, out of the regular network, to attach to the IDS to monitor, to extract the data, to see the log. And that is the traditional physical box deployment. So the internal attacker, if they want to attack the server, or the outside attacker wants to attack the server, they have to all flow through. The data has no other choice but to flow through the physical interface of this switch. This is like a checkpoint. Then you can see, you can do examination of the communications between the server and either the regular user or the internal or the external attacker. Now, as the industry evolved, we actually started to integrate the IDS and a lot of other functions into a single box. We call it security appliances. So in this second variation in the figure 2, we do also have a box. In our class, we use the ASA virtualized or pfSense. Those are the two flavors we're going to cover throughout the course, which is an integrated Snort or IDS IPS package manufactured by Cisco or other either the industry or the open source vendors. So it's not only just a firewall device, but also it's an intrusion detection box. So in this scenario, the inside attacker, if we use a switch coming here, then it's no longer going to go through the physical path. So therefore, if we implement it this way, if we move the physical IDS into an integrated device of a security appliances to a firewall, then the internal one no longer will be protected. So we have to be careful about how we deploy our topology. Now, the management remains the same. The management box, it could connect it to your regular network. However, it's definitely recommended, and it's a big security issue that if you extract the data going through the regular network band, because you try to get a report that's stored in here, the IPS report, then you are actually using the same communication as the attacker. That's a no-no. So therefore, we use the out of band, meaning that we have another network interface card and connect it to this box and access the firewall to manage the firewall. It's a management port. Usually, most of the modern security appliances will have a port designated as a management port, that it doesn't communicate through any other port, but that port itself to the management system. So now in this case, the internet attacker will be still protected. All right. So it tells you that the inside attack is no longer subject to the inspection. Now we have to solve the issue. In here we can actually put this server into a different backbone or different switch, physical or with the figure 3, virtualize it and put it into a different network that's connected with your security appliances. So we can call this one, and if we move it, it will be in a DMZ zone. So this is a DMZ or internal secure, whatever you want to call it, but it will be connected with a different network, either physical one or virtualized, and to the security appliances. Then with that key in place, then the internal attacker wanted to access the server, it will not go through here and access the server directly. It has to go through still the intrusion detection box and go through a different interface to the server, and which will be detailed in the figure 3 here. In figure 3, we actually virtualize everything, and this is what we have done in the Mount classroom, and also in our remote Horizon client exercise, the lab environment, and we'll go into the detail later as the semester goes. So this is the box that's virtualized with the IPS, IDS, let it be Cisco or PFSense or any other box or security onion, whatever the box is. It's virtualized and put it into either a host machine or an EXI server, or you can even move it into the Amazon. That's the same. If you move this box to Amazon, then you will move your server and you use the image also into Amazon, and you will stay from outside internet and access it exactly the same way as if you host it yourself here. So that's why I explained it here. Now we are going to, in fact, all the equipment, it may be virtualized and hosted at your private cloud or public cloud such as AWS or Microsoft Azure. Now, the idea of the concept is this: we move the server into a green network. Green we consider a secure network. At least in my course, I like to use different color code. And the blue one is like a DMZ, and that's somehow exposed or with a lot of workstations. So the green one is your server farm network, and the blue one, it could be your inside user network in there. And this one, even though I put a blue color in here, this is so-called out of band management. So this is not the same network as the inside user network. So you can see if the IP network here is 10.02, And this one will use IP number 192.168.1. So it's not only layer 2, they are using different Ethernet ports, but also, of course, they are on a different layer 3 IP addresses. All right. So in this case, for the internal user here, if they need to access the server, they will go into here. Whether this box is physical box or virtualized or in here, they will use the same interface here to come in and then go through the internal interface of the host and access different network. Therefore, it's going to go through the IPS inspection here. And for the management box, it will be going through a separate network interface coming in and access the database that's being stored in the security appliances here. And so outside attack has always been inspected or protected from. So those are the three topology. And from the very traditional, physical box into virtualized, integrated security appliances, and to further virtualize the whole thing into either your private cloud or the public cloud. So for the intrusion detection and prevention systems, and there are certain basic concepts, pretty self-explanatory, and I will not go through that. I will just go through the highlighting here. For the system, there's a stages to be, if it's to be compromised, they will go through a few stages. First one is reconnaissance, where it's a planning. You try to do social engineering, or you gathering information. The user try to get information from the target. And then you're doing the enumeration, where you can find out which IP addresses and what port that is opening. And we will then start to be more specifically to scan or search using the tools such as a map or scanning tools to find the vulnerabilities. And then once you find a vulnerability, then we will later exploit that. The exploit, meaning attack and compromise the system. Then of course, after that, they will steal the data and cover their track. So we will have, throughout the course, we will have the detailed exercises for you to go through all different stages to get familiar with what happened in an attack and how do we mitigate it. Now, there's certain virus and worms, and SQL SQL Slammer is the one that we will use it quite a few times to illustrate the concept, because it only takes one packet to compromise and unpatch the system. So we'll go into detail later when we started to do the exercises. Now for the IPS and IDS, roughly they are three different types. One is a network-based, which is like the one that we have in the figure. It's a network-based. It's not put it in the host. And there's also host-based that you will install the IDS or IPS into the computer itself or into the system itself. So that's called host-based. And distributed intrusion detection system. That means you have multiple ones throughout your network that you will put in different boxes with different IPS IDS, so that you will be able to get a better picture when there's instances. You can see from which IP, from which boxes, that and try to correlate it. And for the IDS and IPS communication, one additional thing I wanted to emphasize again is from the figure 1, 2, and 3 on the previous pages that we just discussed, it illustrates the use of the out-of-band network sensor management and also the communications. Okay. Now for the IDS IPS, it's all about lock. IDS IPS itself is a packet sniffing services, pretty much. You have to lock all the packets and then you try to analyze it. Basically, a few flavors. The most basic one are three of them, so known as the signature-based. That you create a rule and find out the match of a vulnerability or an attack. And once you find that, then hey, this packet or this stream of packets, it will be triggering an IPS alerts. And the other one is protocol-based, protocol analysis. See if the packet or the communication has been in between the server and the client, is it comply to the protocol rules? And sometimes the attacker will use the illegal, will violate the protocol rules. For instance, it's not supposed to have all the TCP/IP flags. Usually, the basic ones say three-way handshake, sing, act, and act, and then also other quite a few different flags. Usually, you wouldn't have it all turned on, but in the classic attack, they might turn in everything, turn on every flag. So that is actually a protocol violation attack. So we have to also, your IDS IPS will also have to understand a protocol rule. And that's why in the first part of the semester, we will cover TCP IP basics, okay, to understand the IP protocol rules. And we will go in there later on to craft the packet. To change the packet, but we also have to worry about the checksum, and we will have to understand the protocol structure quite well in order to perform packet crafting to regenerate certain vulnerability assessment. And another one is anomaly detection, meaning that we define a normal or abnormal activities. For instance, if you have simple network SNMP, simple network management protocol to manage your printers, and it's supposed to have roughly around 5,000 packets on daily activities, and it suddenly become 4 million or a lot of those SNMP packets. So it's beyond the threshold of the normal. Therefore, it will trigger an alert. So those are the way that we will deploy or monitor through your file, through your IPS and IDS. And throughout the semester, we'll go into more detail about that. And of course, once you have an instance, then you will have to respond to it. They are passive, active, and inline. So active response, basically, you can actually spoof the reset so that you can disconnect the questionable connections and do so on and so forth. But one most important thing is do not retaliate, okay, or the offending host, because they themselves may be a victim as well. Usually, attacker will not attack from their host. They will take over, compromise a computer and use that computers, we call such a computer zombies, and use those computers to launch the attack. So if you attack those zombies, then they just been victimized twice, and we may be also liable to launch the retaliation on that. So gotta be very careful about that. And there's inline IPS, which we will cover that as well. And they can do active response right there, right then. And we will compare the inline IPS using Snort with the PFSense as opposed to using the commercial box Cisco IPS doing the inline response. For the end of this document, there are a few topics I would like you to discuss that. The most important one, I just listed one that happened recently regarding the SolarWinds, the so-called supply chain hack. That it just happened recently, and what happened is that SolarWinds is a big network security and management company, and a lot of government agency and a lot of big corporation, they purchase SolarWinds Orion software to monitor the whole network. And I have quite a few clients that we also use that. So what happened is they will have a periodical patch. And unfortunately, SolarWinds got compromised. So the patch, including the malware in the patch. So it got distributed out. SolarWinds call it Sunburst. Well, good name, go figure. So the patch been deployed to all of the customers, roughly about 18,000 of them, which is a huge customer base, and also with a lot of government agency as well. And once those government agency and those customers install the patch, then they get compromised. And the way it's very difficult to discover this kind of attack, because all of those patches has been signed by a trusted vendor. And so that you will not get any alert once you install it. And then antivirus and the firewall, it wouldn't catch it because there's no signature out there. And they are very still, meaning that they are very quiet attackers. They choose those government agencies for the very high value client to attack. So they don't generate a lot of traffic or noise. So it's been going on for a long time. Therefore, it's very difficult to detect. And the reason why we detected in the US is the FireEye. There's a company manufacturing a lot of vulnerability assessment, attacking in short, another term for vulnerability assessment tools. The company's tool got stolen, got compromised. And during a double password reset error message, they trigger a user's a question mark. The user did not request any password reset. And then the company started to look into the detail and find out that they got compromised. And the sources coming into been investigated and related and pointed towards the Orion software, which is the SolarWinds network monitor software, has been compromised through their patch. And that triggers the whole thing. And it's a big event. How to mitigate that? It is a very difficult, if not, I wouldn't say impossible, but it's very, very difficult to prevent it from happening again, because we have to rely on certain supplier. So that's why it's called supply chain attack. Think about it. If say, for instance, Microsoft, they got compromised in their patch, and we all pretty much install Windows Update. Just imagine what kind of disaster that's going to be, and how are we going to prevent it? And this kind of fact, this SolarWinds Sunburst vulnerability, it also deploy a DNS reverse DNS lookup to actually doing an outbound access to connect it to the attacker, and which we will do quite a few of those exercises also during the network monitoring. And it's particularly to actually monitor system that's not supposed to go to certain website to do, or certain sites to connect with an unknown sources. So outbound used to be wide open for most of the corporations, and now outgoing traffic also has to be examined and looked at very closely. Yeah. So this is the quick introduction for what we will do and what the purpose of what the objectives of this particular course.